Okay, today in Honors Chemistry, we are continuing with Chapter 10, the mole, and we're going to talk about how you calculate the percent composition of compounds. So, percent composition is the percent by mass of each element in a compound. So, to find percent by mass, you take the mass of the element in the sample divided by the mass of the sample times 100, and that will give you your percentage of that element. I guess I should call this percent composition. Let's change that. Okay, so we're going to find the percent composition of Cu2S. So the easiest thing to do is you're going to need your periodic table, and obviously you're going to need a calculator. So we've got 2 copper, so copper's mass is 63.5, and so we're going to multiply that times 2 since we have 2. So that gives you 127 grams of copper, so I'm going to write that above it, plus sulfur is 32.1. So remember, we're doing these to one decimal place, rounded correctly, and you're going to add those two masses up. So the mass of the compound is 159.1. So you'll find percent copper is equal to, you take its total mass, which is 127, divided by the mass of the compound, which is 159.1. Your grams will cancel, times 100, since we're finding percent. And then we're going to do sulfur the same way. Percent sulfur is equal to, sulfur's mass in the compound was 32.1 grams, out of the compound that weighed 159.1 grams total, times 100. Now, we're going to carry our percents out to 2 decimal places rounded correctly. So we're going to take 127 divided by 159.1 times 100 would give us 79.82% of our compound is copper. And then sulfur, sulfur's mass was 32.1 divided by the total mass of the compound, which was 159.1 times 100, and that should be 20.18%. You add up your percents, they should equal 100. Okay, so let's try NaCl. So Na's mass is 23, chlorine's is 35.5. So we're going to add those two numbers up. That is going to give you 58.5 grams. So percent sodium is equal to the 23 grams sodium divided by the mass of the compound, 58.5 grams, times 100. Then we're going to do the same thing for chlorine, percent chlorine. Its mass was 35.5 divided by 58.5 grams times 100. Your grams will cancel. Remember, we're going to carry these to 2 decimal places rounded correctly, so you're going to take 23 divided by 58.5 times 100. So sodium's percent out of sodium chloride is 39.32%. And then chlorine's 35.5 divided by 58.5 times 100 should be 60.68%. Once again, check to make sure these numbers add up to be 100. Okay, the next one is a little bit different. So it says you have an 8.2 gram piece of magnesium. It combines completely with 5.4 grams oxygen to form a compound. What is the percent composition? So the easiest thing to do is just write you a simple equation. Write your numbers above. So we have 8.2 grams of magnesium, and we have 5.4 grams of oxygen. We know the law of conservation of mass says the mass of your reactants must equal the mass of your product. So we're going to take 8.2. We're going to add to it 5.4. So our compound should weigh 13.6. So we're going to say percent magnesium is equal to 8.20 grams divided by 13.6 grams times 100. Percent oxygen is equal to 5.40 grams divided by 13.6 grams times 100. So 8.2 divided by 13.6 times 100. So it's 60.29% will be magnesium, in the compound. And then 5.40 divided by 13.6 times 100, 39.71% of the compound should be oxygen. Okay? Okay, so if you want to put me on pause for a second and then you work your example problems, that would be great. All right, so in PbCl2, the compound weighed 278.2. So your percent lead, you take 207.2 divided by 278.2 times 100. You should have 74.48% of that compound is lead. And then chlorine's mass, you have 2 chlorines, so that is 71 divided by 278.2 times 100 would give you 25.52%. Potassium chloride, potassium is 39.1, chlorine is 35.5, so when you add them up, that compound weighs 74.6. So your percent potassium is equal to 39.1 divided by 74.6 times 100. So that is going to be 52.41%. Your chlorine's mass was 35.5 divided by 74.6 times 100. So your percent chlorine is 47.59. Okay, the next one asked you just to find K. So you're going to look up 2 Ks. So K is 39.1 times 2 is 78.2. Your sulfur is 32.1. And 4 oxygen is 64. So when you add those up, 78.2 plus 32.1 plus 64 should give you the compound weighing 174.3. So your percent K, you take the total mass of the K, which is 78.2, divided by 174.3 times 100. So that compound is 44.87%. Okay? Okay, so the next thing, we're going to use percent as a conversion factor. I could show you how to do that, but I'm going to show you what I think is a simpler way to do these problems, okay? Okay, so we have 82 grams of C3H8, and so in essence, what we want to do is we want to find out of that 82 grams C3H8, how much of it is just carbon. So the simplest way to do these, you write down 82 grams C3H8 times, we want to get rid of grams C3H8, so we're going to put it in the numerator. And we want to go to grams carbon on the top, okay? Okay, so we're going to go to our table. We're going to look up 3 carbons, which is 12 times 3 is 36, plus 8 hydrogens, so we're going to add 8 to that. So C3H8 weighs 44 grams. Of that 44 grams, 3 of those are carbon, so 3 times 12 is 36, okay? So your grams C3H8 cancels, and you're going to be left with grams carbon. So you're going to take 82 times 36 divided by 44. So out of that 82 grams C3H8, 67, oops, I did something wrong. 82 times 36 divided by 44. Out of that 82 grams of C3H8, 67.1 grams of that is actually carbon. Okay, so now put me on pause for a second and see what you get on the 2 examples, or the practices. Okay, so you've got 124 grams calcium acetate, Ca, C2H3O2, 2 times, we want to get rid of calcium acetate, Ca, C2H3O2, 2, and we want to know grams hydrogen. So when I add up the mass of this compound, it should be, if I'm not mistaken, 158.1 grams. And we have 2 times 3 is 6 hydrogens, so that is 6 grams. So you're going to take 6 times 124 divided by 158.1. And so of that 124 grams, there are 4.71 grams that are actually just hydrogen. Okay, the amount of nitrogen in 378 grams HCN. We want to get rid of grams HCN. 2 grams nitrogen on top. Okay, so we have 1 for your hydrogen, we have 12 for your carbon, and 14 for your nitrogen, so that compound weighs 27 grams. Of that 27 grams HCN, 14 grams are nitrogen. So we're going to take 14 times 378 divided by 27. So 196 grams of that compound is just nitrogen. Okay? So that gives you the information you need to do set 2 of your homework. Thank you.